Good morning, everyone. Welcome to another edition of Chemistry on the Fly with Mr. F. Today we're going to talk about 4.50 polar water. Now, we're going to find out that water has a whole bunch of magical properties. And the first one that we're going to talk about today is going to be water bending. You're going to say, uh-oh, how can water bend? You know, it's liquid and I can't even grab onto it to bend it. Well, if I take a stream of water like this and I bring in something that's plastic, like this pink flamingo, I can actually, and hold it really close, I can actually bend water. Now, you might think, like, why did I pick a pink flamingo? Well, I wanted to thank a video that I saw, thank Bruce Yaney, and he used a pink flamingo to demonstrate it in his demonstration, so I thought I would use it in mine. It's a pretty cool video, and the link is right below if you wanted to check it out. Another magical property of water is that it is the universal solvent, which means that if I take salt and put it in water, it dissolves. If I take sugar and put it in water, it also dissolves. If I take a chemical like copper 2 chloride and I put it in water, it actually dissolves as well. So water is the universal solvent. Now, we can walk on water too. Well, we can't walk on water. Jesus might have done it a long time ago, but we can't, certainly can't. But there are certain critters that can walk on water. Now, it's not really the critters that can do this, it's actually a property of the water that makes this possible. Kind of magical. Now, if you keep on doing that, here's another magical water property. Water can actually defy gravity. Now, what do I mean by that? It's not like I'm going to pour water on the ground and it's actually going to go up. No, it can't do that. But if I take a beaker and put a little bit of water in it and some red food coloring so I can see it, and I put a piece of filter paper in, I can actually let it wait and the water will actually get absorbed by the filter paper and it will actually rise. So, technically, water can defy gravity. Another magical property of water is that ice floats on it. We've all seen this before where we pour water over ice and the ice will actually float to the top. We've talked about this earlier is because that the ice is actually less dense than the water. However, we don't usually see this in other materials. Most materials, when they freeze, they actually become more dense than they are when they are liquid. So this is again a very magical property of water. Hey Albert, what's going on?
It's not magic, it's science.
Ah, thank you very much, Albert. What gives water all these cool properties? Well, it turns out that water is a polar covalent compound. Let's review. Remember, water is H2O. We have 2 hydrogens and we have 1 oxygen. The 2 hydrogens have green lights on their valence electrons, and the oxygen has 2 stops on the 2 of its sides, but it also has 2 greens as well. The hydrogen's then going to match with the oxygen, and the other hydrogen is going to match with the other oxygen as well. So now I have three happy atoms. I have oxygen is happy, and my two hydrogens are happy. Oxygen's happy because it has 8 valence electrons around it, and hydrogen's happy because it has 2 valence electrons around it. Now, the electrons that we have between the hydrogens and the oxygens are both shared. But we learned that the electrons are not shared evenly. If you remember, we have a strong oxygen and a not so strong hydrogen that are competing against the electrons. Now, in the past, I showed you that oxygen had the electron all the time. Well, that's not quite the case. It's more like this, where the oxygen's going to have the electron more often. And if I were to take a snapshot, I would actually be able to see that the oxygen has that electron much more often than the hydrogen, which is going to give it a partial charge, and the oxygen side of the water molecule is going to be partial negative, and the hydrogen side is going to be partial positive. This is actually what's going to make our water molecule a polar covalent, because we have unequal sharing of these electrons. We're going to look at a new model today of water. This is a spherical model. This goes back to kind of like what Dalton was talking about with everything being small particles. And we have the spherical model. So here's our spherical model that we're going to use today. And we can see that we have a large red atom that's going to represent oxygen. And I have two smaller white spheres that are going to represent hydrogen. As always, I'm going to have a partial negative charge on the oxygen side and a partial positive on the hydrogen side. Now, most people, a lot of people, call this the Mickey Mouse molecule. Now, I don't know. What do you think? Well, let's ask Mickey.
Well, frankly, I don't see a resemblance at all.
Thank you, Mickey. Hey, look, it's Albert again. What do you got to say, Albert?
It's not magic, it is science.
Thanks, Albert. Just like Albert told us, it's not magic, it's science. So let's do this. Let's make these revealed. How can I bend water? Well, here's a blow-up view of what we've got. Okay, I have the water stream coming down, and I showed a bunch of different water molecules, all kind of randomly placed. This is what I believe the water's looking like. Now, when we bring the flamingo in, it's actually coated with electrons. Now, what Bruce did in his demonstration is he rubbed the flamingo with a cloth. The cloth gave up its electrons to the flamingo. So now it's negatively charged. Now, with the negatively charged flamingo in the area, what's going to happen is that the positive hydrogen parts of the water molecule will then be attracted to the negative flamingo. And conversely, the oxygens will be repelled because they're partial negative. We just revealed how we can bend water. That was one of our magic tricks that we can reveal. As Albert once told us,
it's not magic, it's science.
We'll reveal some more magic, science, next time. That's it for today. It's Chemistry on the Fly with Mr. F, and as always, have a great day.